So the last thing we did last time was talking about angular velocity. So before I move on, maybe I'll just ask, do people have any questions specifically on that topic? Converting between angular velocity and linear velocity. All right, cool. So then let's introduce the 6 functions that will occupy our attention for the remainder of the semester. So-called trigonometric functions. Extra credit on the topic of spinning gears. So the first thing that I want to point out is a picture in the notes on this page, done in landscape so that it's big. We'll fill in this as we go. This will be a lookup table for the values of the trig functions. And we'll see it in action during the course of today's lecture. So let's introduce the trig functions. Oh, the other thing is this is one-sided with the idea that you can, if you want, remove it from your notes so you have a copy of it. I'm not going to because I will surely lose it, and I don't need a note sheet for exams. So let's talk about the trig functions. So here's the game. Let's start at 1, 0 on the unit circle. Draw a picture. I'm going to draw it right here. There is a perfectly round circle of radius exactly 1. Its center is at 0, 0. So it's one of its x-intercepts is at 1, 0. Start at that x-intercept. Start at 1, 0. Rotate counterclockwise by an angle of theta. And see where you land. You'll land at some point. That point will have some xy coordinates. Let's just give them names for now, x and y. The trig functions just record the point that you land on. Cosine of this angle theta recovers the x coordinate. And I'm going to put this on the board so that it's easy to see after I flip to the next page. The sine of theta records the y coordinate. Oh, one thing I should do, because sometimes people are very quiet and just don't speak up. Does anyone need a copy of the notes? I actually have them today. Okay, very nice. The secant of x records the reciprocal of the x coordinate. The secant of theta records 1 over the x value, unless something happens. If I want to divide by x, what had x better not be equal to? 0. If x is 0, then sine of theta is just going to be undefined. Secant of theta is just going to be undefined. The cosecant of theta is the reciprocal of the y coordinate. And of course, the bad thing that could happen is if y is 0, then it's not defined. The tangent of theta is the y coordinate divided by the x coordinate, which is defined unless x equals 0. The cotangent is given by the x coordinate divided by the y coordinate, unless the y coordinate is 0. People feel pretty okay? And if you want more geometric intuition about what these things mean, then I will in fact drop an advertisement to the extra credit in 6.6. So it turns out all of the trig functions have to do with different distances in this diagram. And that's what the trig functions are made to recover. But let's give like one piece of intuition for one more of the trig functions. So let's look at this line that I drew here from 0, 0 to xy. What's the slope of that line? So this line goes through the point xy and it goes through 0, 0. So what is its change in y? Negative, but more specifically, it's negative 1. That's negative y, right? Right, so this, if you're reading off this way, then the rise is negative y. How big is the ln? X. Well, actually, negative x, the way we're thinking. So what's the slope of this line? So it's change in y divided by change in x, right? So it'll be, or rise over ln, I guess we're using the words we've been using. Negative y over negative x, which is just y over x. Oh, cool. Is that just one of the trig functions? It's tangent. So this value tangent, just to recover, is this slope. If you rotate forward by some angle theta, this time I'll use an angle that is in quadrant 1 instead, then you get some line after you rotate by that angle. The tangent is the slope. That seem okay? Nice. So there's a piece of geometric intuition for what tangent means anyway. So if these are functions, we should be able to evaluate them at least sometimes. Right? Like sometimes it's hard to evaluate functions. Like if I ask you what the ln of 7 is, like, I guess you can figure out somewhere between like 1 and 2 probably. More than that is hard. Same thing with trig functions. Some numbers are hard to plug in manually, some numbers are easy. What we're going to do here is plug in some numbers that are easy to plug into trig functions and see if we get enough and then see what we get. So let's evaluate some trig functions. So let's start by thinking about pi over 2. Let's compute all the trig functions at pi over 2. And let's do it by following the instructions that define the trig function. So start at the point 1, 0, and then rotate forward by pi over 2 radians. And what sort of angle is pi over 2? How big an angle is it? It's not acute. It's right at the edge of what is between acute and obtuse. It's a right angle. Pi over 2 radians is 90 degrees. This is a right angle. So if you start at 0, 1 and you rotate forward by a right angle, what point do you land on? What point is that? 0, 1. So that means the x-coordinate is 0, the y-coordinate is 1. All right, so what's the cosine of pi over 2? Zero, because it will be the x-coordinate you land on, which we just saw was 0. What about sine? It's the y-coordinate. The y-coordinate is 1. Take a moment, fill in the remaining rows, and then we'll talk through them, and then we'll flip back to this unit circle page. Unless you tore yours out, then I guess you don't have to flip back. All right, so let's come back. What's the tangent of pi over 2? It's undefined. You end up having to divide by 0. Tangent is y over x. That's 1 over 0 is undefined. I guess from like the slope of a line perspective, the line whose slope you want to compute is vertical. Vertical lines don't have a slope, or if they do, you would say that it's slope infinity or minus infinity. So you just don't talk about that slope. It's undefined. How about secant? Also undefined, because x is 0. Cosecant? Cotangent? 0. Neato. And now I'll flip back to that page myself. So that means you should be able to put into this entry when you rotate by an angle of pi over 2 radians, you should end at 0, 1 is the point you land on. And then this last number is labeled as being tangent. Tangent is undefined. Oh, and notice, if you just know x and y, then you really know all the trig functions, because they're all determined in terms of x and y. I didn't finish writing that on the board, I should. Nice. So, let's do it again. Let's think about an angle of rotation that is pi radians. And let's see, 2 pi radians is a full revolution, so pi radians should be half of a revolution. So if you start at 1, 0, and you rotate halfway around the unit circle, or by 180 degrees if you like thinking about degrees, what point do you land on? Negative 1, 0. All right, yeah, the angle is pi, the point becomes negative 1, 0. So x is negative 1, y is 0. And now I'll fill this in. So cosine will be the x-coordinate, sine the y-coordinate, tangent is y over x, secant is 1 over x, cosecant is 1 over y, cotangent is x over y. So with that done, by looking at this diagram then, what is the cosine of pi? Negative 1. What's the sine of pi? Zero. Sine of pi is 0. Tangent of pi? Yeah, I think it's 0. Let's go through and write it down. So tangent will be y divided by x. Y is 0, x is negative 1. 0 over negative 1 is 0. How about secant? I think that one's negative 1. Cosecant? Undefined, because the thing you're dividing by is 0. Cotangent? Undefined. Nice. So now I'll flip back to that page. I think that here's the thing we can do now. If you rotate forward by pi radians, I guess you can see things in this diagram that maybe aren't obvious at a glance, but maybe you think about for a second in there. You could also rotate backwards by half of a full revolution and get to the same point. You land at the point negative 1, 0, so cosine is negative 1, sine is 0, tangent is 0. Groovy. And maybe as a comment, I don't know if I said this verbally, if you want something like this on a note sheet for a future exam, that's allowed. You can have exactly this diagram on your note sheet in the future, but it's like really big, so maybe you want something that actually allows you more space to write. Nice. All right, so let's make one quick calculator check. So as I said, a lot of things, if you want to plug them in, will be hard to do by hand. We'll use a machine. But let's test this machine first. So use your calculator, and here's the thing that we just computed. We computed the cosine of pi over 2. We got it to be 0. Using a calculator, compute for me. Have a calculator compute the cosine of pi over 2. And I guess if you don't have the calculator on you right now, that's okay. Everyone seems to. No, you don't. Okay. So, cool. So, tell me what you get. What are the numbers people get when they plug into the calculator? Anyone get a thing that's not 0? What'd you get?
Well, it was 0.99, and then I changed my calculator into radians.
Yeah. So cosine of pi over 2 radians is 0. Radians is always what you assume if you're not told otherwise. If you happen to be in degree mode, cosine of pi over 2 degrees, well, pi over 2 degrees, that's like 1.5 degrees. So that should be like basically, well, this will be about cosine of 1.5 degrees. So that should be like starting at 1, 0, rotating forward by basically nothing. You should be basically at 1. Which you saw that you won't. So whenever you make any of these calculations, you should check whether you're on degree or radian mode and make sure that you're in the right setting for the context that you're in right now. And just maybe to demonstrate that you're not always going to be in radian mode, let's think about the following. Let's compute by hand the cosine of 90 degrees without a calculator. So, if you start at 1, 0, how big an angle is 90 degrees? What type of angle is that? It's a right angle. So if you start at 1, 0, you rotate forward by a right angle, what point do you land on? 0, 1. So what's the cosine of 90 degrees? 0. But now if you're not very careful and you leave your calculator in the same mode as it was before, what does the calculator tell you cosine of 90 is? Something that's not 0, probably. What do you get?
I got -0.44.
That sounds reasonable. So cosine of 90 radians is not the same thing as cosine of 90 degrees. Whenever you use a machine, you should think to yourself, you should pause for a moment and think, am I in radian or degree mode? And then at the end, you should also ask yourself, is this an answer that's reasonable? Which a negative thing definitely wouldn't be based on the intuition we just got. Nice. So, people feeling good? All right. So, let's do one more. So, you can get some geometric intuition to figure this out. But we won't right now. We'll do this next time. It turns out that if you start at 1, 0, and you rotate forward by an angle of pi over 4 radians, or if you like 45 degrees, then you land at the point root 2 over 2, comma root 2 over 2. So based on that fact, tell me, what's the cosine of pi over 4? Root 2 over 2. It'll be the x-coordinate. What about sine of pi over 4? Also root 2 over 2, because it'll be the y-coordinate, which is also root 2 over 2. How about tangent of pi over 4?
1.
Yeah, so you said the 1 with confidence, which is good, because the 1 is correct. Should I go through the walk to get it at all? Nice. So, maybe I'll ask you then the summary. Why 1? It'll be the y over the x. And what is y equal to? And what about x? Also the square root of 2 over 2. And I want to focus on that walk also. It's a thing divided by itself. What's a thing divided by itself always equal to? 1. Unless you're dividing 0 by itself, then it's just not defined. Neato. That feel pretty good? How about cotangent?
Also 1.
Also 1 by the exact same argument? Oh, neat. So that means that, like, tangent and cotangent are really closely related. They're just reciprocals of each other. So once you know tangent is 1, I guess cotangent should be 1 over 1, also 1. How about secant of pi over 4? It is 1 over the x value, which is the square root of 2 over 2. Does that look like something that should be simplified? Yeah, there's a fraction in the denominator right now, so that's already something you should simplify. How do you rewrite that so you don't see a fraction in the denominator? How do you divide by a fraction? Multiply by the reciprocal. So that's 2 over the square root of 2. So that's simpler looking anyway, but now I see a square root in the denominator, which is something that, especially starting now, I'm going to harp on a lot. I don't want to see square roots in the denominator when avoidable from now on. So I want to get that square root out of the denominator. What should I multiply and divide by to get rid of that square root? Square root of 2. Because what's the square root of 2 times the square root of 2? 2. So doing that, I will multiply by root 2 and divide by root 2, getting me 2 root 2 divided by 2 times the square root of 2 will be the square root of 2 squared. Square roots undo squares, so in the denominator we just get 2. So that's 2 square root 2 divided by 2, which is equal to just the square root of 2. And maybe now I'll point out, does that final answer look way simpler than the thing we started with? Yes. And secant of pi over 4 is a quantity that we will refer to, not with a huge frequency, but with enough frequency that it would be super annoying to have to write down 1 over the square root of 2 over 2 every time I wanted to use it. How about cosecant? Yeah, it's the same thing. You'd start with the first step. It's 1 over y, 1 over root 2 over 2. Oh, look, that's verbatim the same as the previous thing. Nice. So let's just make one observation. You can walk in degrees or radians. We just made a computation in radians. Let's figure out what degree count they gave us. What is pi over 4 in degrees? 45 degrees. Did you do that by computing or just by knowing? Yeah, that's fair. Let's do it by actually computing it. If you don't have a bunch of these conversions memorized already, you probably will within a few weeks. So let's convert from pi over 4 from radians to degrees. So pi over 4, right now it's in radians. What do you multiply by to get to degrees?
pi.
180 over pi. Right, it's either pi over 180 or 180 over pi. And let's see, the degree measure of an angle will be way bigger than the radian, so you want to multiply by the thing that's big, not the thing that's small. So that's by 180 over pi. And this will give me the degree count. And now we just have to do it. So happily, the pi's cancel. We get 180 over 4. 180 is even, so that's 90 over 2. Half of 90 is 45. So let's just write one thing down. As a consequence, what's the cosine of 45 degrees? Well, 45 degrees is the same as pi over 4 radians. And we've already computed cosine of pi over 4. Root 2 over 2. This will be exactly the same as that. Neato. Folks feel pretty good? So, looking back at this lookup table, I'm not going to put this value in the lookup table yet because I don't feel like, I don't know why it's here. I haven't explained that. So I don't feel like I deserve to put it in the table yet. You can if you want to. But you'll notice that there are, like, in each quadrant, 3 numbers that will be difficult to compute by hand. But one thing you can do by hand fairly easily is tell whether the result of computing a trig function will be positive or negative. And let's see that. Oh, son of a diddly. No, I'm getting ahead of myself. No, well, we can do that. We can do that. Well, okay. I'll go back to this table in a second. So let's try to answer this question. So here are a bunch of trig functions evaluated at 2 pi over 3. This exercise is just going to have us decide whether these things are positive or negative, not figure out what they're actually equal to. So, in order to do that, let's figure out what quadrant 2 pi over 3 lives in. And let's do that by drawing a picture of the unit circle. So I know that This angle is 0 radians. This angle is pi over 2 radians. This is an angle of pi radians. And so let's just ask first, 3 pi over 2, is that between 0 and pi? Oh, sorry, 2 pi over 3. Is 2 pi over 3 less than pi over 2? Yes or no? Well, I want both. So let's see show of hands. Folks, for the answer to that question is yes. Folks, for the answer to that question is no. All right. Folks, for it's not clear. Cool. Let's talk about how to compare size of fractions. So on the one hand, you could bust out a calculator, but I want to do this whole exercise sans calculator. So there's a fraction. I would like to know whether or not it's true. Let's figure out whether or not it's true by simplifying. Could I clear denominators here? Yeah, the denominators are all positive, so I won't be multiplying by a negative, which would screw up an inequality. So let's multiply those over. That'll get me 4 pi is less than 3, because 2 times 2 is 4. 3 times pi is 3 pi. Question mark. Is that inequality obviously true or obviously false? Obviously false, because 4 is not less than 3. Right, you could take that and divide by pi. It becomes, is 4 less than 3? No. 4 is not less than 3. 4 is bigger than 3. So, what that tells me is 2 pi over 3 does not live here. Next, let's try to decide, is 2 pi over 3 in this range? And so I guess to do that, you have to ask, is 2 pi over 3 less than pi? And so think on that for a second. Ask yourself, is 2 pi over 3 less than pi? Folks for yes? Folks for no? Folks for it's not clear? Let's go through the exact same motions. Let's take that inequality, which we would like to know whether or not it's true, and just simplify it until it becomes obvious. What's something we could do to both sides of this inequality to simplify? You could multiply by 3. It would become, is 2 pi less than 3 pi? Is that obviously true or obviously false? It's obviously true, because right, 2 is less than 3. So, what that means is 2 pi over 3 is in here. It's in this range. It's about there-ish. All right, so let's go back to this question as written. So, in what quadrant does rotation by 2 pi over 3 put you? Quadrant 2? So using that fact and that fact only, let's determine whether these trig functions are positive or negative. And we'll start with cosine. Cosine of 2 pi over 3 will be the x value. In quadrant 2, is the x value positive or negative? Negative. So this result will be negative. What about sine of 2 pi over 3? It'll be positive, because it will be the y value that is above the x-axis. This y value is positive. Tangent? Negative. It will be the y value divided by the x value. That'll be a positive divided by a negative is negative. Cotangent? Negative. Secant? Cosecant? And people were very quiet during that. So what that suggests to me is maybe some people would like to see more discussion. Is there demand for more than the fairly lack discussion that I gave on the individual as a positive or negative? All right, cool. Let's pick one. Let's pick tangent. And I've got space right here. So what we found previously is 2 pi over 3. An angle of 2 pi over 3 lands in quadrant 2. So if you rotate by 2 pi over 3, I guess really I only want the positive half of this line. You wind up with a ray that points in that direction. That ray points in quadrant 2. That's already written. In quadrant 2, well, let's look at the x value first. So this point lives to the left of the y-axis. So the x value is negative. I don't know exactly what the x value is, but whatever it is, it's definitely negative. The y value is positive. So far, so good? So that means that the tangent of theta, if I want to compute tangent, will be y over x, will be a positive number divided by a negative number. And if you take a positive and divide by a negative, what do you get? A negative. Which hopefully agrees with what's right there. Nice. Cool. Does that feel kind of okay? So if you care whether a true function is positive or negative, just look at the input and ask yourself what multiple of the right angle it sits between. Then use that to decide what quadrant it's in. So here's the next thing I want to do. Let's take this table. This table is going to evaluate trig functions at some right angles. And some of them we've already done. We already worked out pi over 2. By stuff we already did. What's the cosine of pi over 2? Either by flipping to that previous page or drawing the picture again. Sine of pi over 2? Tangent pi over 2? And in interest of time, I'm going to focus on just cosine, sine, and tangent. These other entries will just be reciprocals of the entries in that table. We also talk about an angle of pi. What's the cosine of pi? What's the sine of pi? And the tangent of pi? 0. So here's what I want to do now. I want to fill in the remaining 3 rows. I think here's what I'll do. I'm going to fill out the first row, and then I'll split you all up and have you think about the remaining 2. So let's think about an angle of 0. And most things when you want to do the 0 to them, either it's like really easy because it's obvious what 0 should mean, or it's kind of confusing because it's not clear what 0 even means. So I think that's the stumbling point here. So let's draw our perfectly circular unit circle. We start at the point 1, 0, and then I don't rotate at all. So if I start at the point 1, 0, and I do nothing, then what point do I land on? Okay, same as I am already. So that means that the x-coordinate, remember the cosine is the x-coordinate, is 1. The sine is 0. Sine is the y-coordinate, is 0. So what's the tangent of 0? 0. Nice. 3 pi over 2. Well, so let's think about what type of angle 3 pi over 2 is. Remember, pi over 2 is a right angle. So 3 pi over 2 is like 3 right angles back to back. So let's start at 1, 0. I guess I can use this exact same diagram. And let's go forward by a right angle 3 times. So there's one right angle, there's another, there's another. So this resulting angle is 3 pi over 2. So if you rotate forward by those 3 right angles, what point do you land on? 0, negative 1. Nice. So now we can make the computations. So what's the cosine of 3 pi over 2? 0. Because cosine is the x-coordinate. What's the sine of 3 pi over 2? Negative 1, because sine is the y-coordinate. What's the tangent of 3 pi over 2? It's undefined, because it would be like negative 1 over 0, which is undefined. That feel pretty good? All right, so the last thing left is 2 pi. So let's suppose you start at the point 1, 0, and you rotate by 2 pi radians. So that's like all the way around the circle. So if you start at 1, 0, and you rotate all the way around the circle and come back to where you started, where do you land? Back at 1, 0. So, by drawing that picture on your page if you need to, or just having it in your head. So what does that mean the cosine of 2 pi should be? 1. What about the sine of 2 pi? Tangent? Oh, notice that's the exact same thing as an angle of 0. So the trig functions don't see 2 pi radians. They think that 2 pi radians is the same as 0 radians. Which I guess makes sense. One polar evolution doesn't affect where you land. Nice. That feel good? Any questions right now? All right. So, the next thing I want to do is going to come back to this idea of what quadrant does an angle live in, and using that to decide whether a trig function will be positive or negative. So, let's fill in some of this table. Not all of it, just a little bit of it, just enough to get by. So, if this is an angle of 0, this is an angle of pi over 2, here's an angle of pi, 3 pi over 2, gesundheit, 2 pi. Let's try to decide for each of these ranges what quadrant that we wind up in. So if you rotate by an angle between 0 and pi over 2, well, that means you're somewhere between 0 and pi over 2. What quadrant do those angles trace out? Quadrant 1. And in quadrant 1, cosine, which is the x-coordinate, will that be positive or negative? Positive. What about sine? Also positive. How about tangent? How about the rest of them? All positive. Secant will be 1 over cosine, positive. 1 over positive is positive. Positive over positive is positive. So in quadrant 1, all of the trig functions are positive. If you happen to have an angle between pi over 2 and pi, that's this range. What quadrant does that sit in? 2. So if you like, this is why the quadrants are numbered the way they are, because if you rotate counterclockwise, this will trace through quadrant 1, quadrant 2, quadrant 3, quadrant 4. So let's ask ourselves, in quadrant 2, will cosine be positive or negative? And I think I'll settle for cosine, sine, and tangent for this. What about sine? Positive, because that y value is positive. How about tangent? Negative, because it will be a positive divided by a negative. Do you think you could fill in the remaining rows on your own? Yeah, which is exactly why I'm not going to fill in these ones. I think I will do at least the first row of the remainder. Between pi and 3 pi over 2, what quadrant do you live in? Quadrant 3. And now just cosine and sine. In quadrant 3, will cosine be positive or negative? How about sine? Also negative. In quadrant 3, x and y are both negative. What about tangent? Positive. Negative divided by a negative becomes positive. 3 pi over 2 to 2 pi, what quadrant does that give you? Quadrant 4. So cosine will be? Sine? Tangent? So let's see what pattern we notice. So between 0 and pi over 2 gives you quadrant 1. Pi over 2 to pi gives you quadrant 2. Pi to 3 pi over 2 gives you quadrant 3. 3 pi over 2 to 2 pi gives you quadrant 4. 2 pi to 5 pi over 2 will give you quadrant. I didn't get it. I'm going to say quadrant 5. Yeah, it'll get you back to quadrant 1. Neato. So, using that idea, this idea of just what quadrant does an angle live in, let's answer some questions about positivity / negativity without using a calculator. We can use a calculator to check. Let's decide cosine of 4. Will that be positive or negative? So, in order to think it through, let's look at exactly this table. Is 4 between 0 and pi over 2? Yeah, because pi over 2 is like 3-ish, so pi is